Here we have a sample problem that says genetic diabetes is an autosomal recessive trait. If 42% of a population has diabetes, what percentage of the population are carriers? And this is actually an old diploma question from when stats were published for how many people got this question right. 35.5% of people got this question right. So people do find it challenging, but it is actually a pretty simple question if you think about it carefully. Big mistake that I think people make in this question is the percentage to probability, because that's going to immediately throw your numbers off. So we are told that 42% of the population has genetic diabetes. It's an autosomal recessive trait, which means Q squared corresponds to it, but is not 42 for Q squared. Q squared is equal to 0.42. And that's where I think people get thrown off right away. You have 0.42 as the Q squared. We don't know what P squared and 2PQ are yet. We're actually looking for 2PQ as our final answer, but we're not there. So once we know what Q squared is, we can solve for Q. It is just going to be the square root. And again, this is why I think people struggle with this question. Because if you take the square root of 42, you're going to get a very different answer than the one that you need. So approximately Q is going to be equal to 65 hundredths. So about 65% of the alleles in this population are the alleles for the recessive diabetes trait. Once we know what Q is, we can also solve for P. It's just going to be 1 minus our Q value, and that will give us about 35 hundredths. So about 35% of the alleles in this population are the wild type dominant. Okay, now that we know that, we want to figure out what the percentage of the population are carriers. Carriers are heterozygotes, so that's going to be our 2PQ value. So 2PQ is going to be equal to 2 times 35 hundredths times 65 hundredths. Again, though, as always, use the numbers in your calculator. Don't use the rounded numbers. You can write down the rounded numbers on your sheet of paper so that you make the math less time consuming, because writing all of those out is a tedious pain in the butt. But you have to make sure you use the actual numbers in your calculator. This gives us 0.456. And I'm including the 6 in there because I know this is a diploma question and I want percentage. Here's the other place I think people make lots of mistakes on this question. You'll notice it has nothing to do with the Hardy-Weinberg math. It's the conversion between the percentage and the probability. The probability is 0.456. If you rounded that to 0.46 and wrote that in on the diploma, it would be wrong because it asks for a percentage. So the percentage of our heterozygotes in this population is going to be equal to 45.6%, which is why I did the 456, because I know diploma, we're going to have 4 digits in our answer. So we've got 1, 2, 3, 4, because the diploma counts the decimal place as a digit, even though it's not a place value on the numerical response sheet. So 45.6% of this population would be carriers. If you wanted to then figure out the rest, and you want to know what P squared is, just for the sake of it, we would take our P value and we would square it. P squared in this population. So our homozygous dominance would be about 12%. So 12 hundredths or 12%. And there you go.